Hi team, now we're going to do a little more pre-work for our trigonometry and focus on what we call reference angles. If you guys recall from last time, we can place right triangles on a coordinate plane like this guy here, where you've got the x-axis, and so this side is the length in x. We have the y-axis, so this side here is the length in y. And then we have our hypotenuse in r, and we've been focusing on that hypotenuse or that radius being 1. What we consider standard position is when the central angle, we'll call it theta, is created by keeping what we call the initial side on that positive x-axis and rotating what we call the terminal side about the origin. So, for example, here, if we consider this to be the x-axis, this is the initial side. And if we rotate it around like that red arrow shows, this angle here is our theta, and this is our terminal side. And when we rotate that angle counterclockwise, we will get a positive angle. Think of it if we were on the XY coordinate axis. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's why the quadrants are numbered actually in counterclockwise order. That's the way our positive angles rotate. If by chance we decide to rotate that terminal side counterclockwise, then we will end up with a negative angle. So we can go, say, positive 30 degrees if we go up to quadrant 1 first, or we can get a negative 30 degrees if we go down towards quadrant 4 first. Let's recall what the sides of a 30, 60, 90 triangle would look like. Here's our 30. Here's our right angle. And this side, we will say that our hypotenuse is 1. But what would happen if we were to reflect that triangle across the y-axis? What angle did it create? Well, if we were to consider this line here to be our terminal side, right? We created this angle here at 30 on the left. But if we rotated it all the way across where this is now our 30 degrees, well, we remember that we have 0 degrees here. If we go up here, it would be 90 degrees. And if we go all the way over, it would be a total of 180 degrees, but we didn't rotate it all the way to the flat or straight angle. We stopped when we had that 30 degrees left. So technically, this angle created here is 180 minus 30, or 150 degrees. But notice, if we rotated that terminal side, we can still create a right triangle here down towards the x-axis. That angle here, this 30 degrees, still gives us a ratio where our hypotenuse is 1, the opposite side is a 1/2, and the x, the length of it, is still rad 3 over 2, but notice where it is on the x and y axis. This gives us a negative x value because it's on the left of the x-axis. X-axis, y-axis. So if we were going to try to find the coordinate point right there of 150 degrees, we would have an x value of a negative rad3/2 and a y value of a positive 1/2. Negative rad3/2 and a positive 1/2. In other words, we can use that 30 degrees as a reference. If we can create a right triangle, be it 30 degrees, 45 degrees, or 60 degrees, the three that we memorized earlier, we can use all of those as reference angles. To determine the x and y values of any angle that is a multiple. So let's do a couple examples. We want to find the x and y coordinates of the following central angles in standard position. So again, let's focus on what the standard position looks like. We still have our x and y coordinates. So let's determine where 300 degrees would be. Well, if we're starting here, where we haven't moved any, that would be 0 degrees. If we moved up to the y-axis, that would be a right angle of 90 degrees. If we moved all the way over to the straight angle, that would be 180. If we went another 90 degrees, that would give us 270 degrees here. And if we went all the way around the circle, added another 90, that would give us 360 degrees as a full rotation. So in our standard position, remember that 300 degrees is positive, so we have to go counterclockwise through the first quadrant, second quadrant, third quadrant, and then fourth quadrant. Now, 300 degrees is about 60 less than the 360, right? So he would probably be about right here. Right, so we'll just call this 300 degrees. But that means if that guy is 300 degrees, then this little angle here is one of the angles we already know, the 60 degrees. Or you could say negative 60 since it's in that angle, but we have 60 degrees left. Well, that will allow us to make a right triangle. And remember, with the 60 degrees, our x value is 1/2. Our y value is rad3/2. And we're still always dealing with a hypotenuse of 1. But we're in quadrant 4. So that means our x value is positive, but any y value down here is going to be negative. So that means this coordinate point here is going to be a positive 1/2 for our x value and a negative rad3/2 for our y value. So if you have forgotten about those special triangles, 30, 60, 45 angles, and what we needed to know about their sides, go back to the special angles and radians section. I believe that was section 1.0.2. So let's do the same here with 135 degrees. And we're going to think of our XY axis, but think of it in terms of degrees. We start here at the positive x-axis at 0. We go up through quadrant 1 to a 90-degree angle. Then through quadrant 2, another 90 degrees gives us 180 degrees. Well, 135 is less than 180, so I know I'm just dealing with those two quadrants. And so 135 would be about right here. 135 degrees. And we can always think about what gives us 135. So if we took 180 degrees minus that 135 degrees, it gives us 45 degrees. So that is what is left here, 45 degrees. And we know the measurements of a 45, 45, 90 triangle. So we can create that triangle always with the x-axis, because that will give us a nice right triangle. We'll have an x-coordinate of a negative rad 2 over 2 and a y-coordinate of a positive rad 2 over 2. So that means this point of a 135-degree angle is a negative rad 2 over 2 and a positive rad 2 over 2. And let's do our last one here. Now this one I gave you a negative angle just so we can get used to the direction. This is still positive 0 degrees, positive 90 degrees, positive 180 degrees. But we're going a negative 150 degrees. That means we're going to be going to through quadrant 4 first and then over to quadrant 3. We're going backwards since it's negative. We're going to go this way. And it'll be roughly there because it's not quite 180 degrees, so it's not going to go past that other part of the x-axis. So if that's 150 degrees, that means this is left to be 30 degrees, right? Because together they'd have to add up to that 180. 30 degrees is an angle we know, so we can create our right triangle again. The side opposite the 30 degrees is a 1/2. And remember, we're in quadrant 3, so that means that y value of 1/2 is going to be negative. But also our x value, which is the longer side here, is also going to be negative. Negative rad 3 over 2. Remember, we're only dealing with a hypotenuse of 1 right now. So this coordinate point for 150 degrees is going to be a negative rad 3 over 2, negative 1/2. So again, before you start on this section for reference angles, be sure that you have memorized those points for the 30, 60, 45 degree angles from section 1.0.2 special angles in radians. Thanks, guys. See you soon.